Have you ever thought about how your daily activities impact our planet? What if we told you you're exhaling part of the problem right now? That's right, folks. The carbon dioxide you just sighed out is a tiny fraction of the carbon emissions we humans are responsible for. Now, these emissions aren't just from your breath, but from various sources classified into 3 scopes. Scope 1 is direct emissions. Think cars and factories. Scope 2 is indirect emissions from the generation of purchased electricity, steam, heating and cooling consumed by the reporting company. And Scope 3, well, it's everything else that's indirectly linked to our activities, like the emissions from producing the food we eat or manufacturing the clothes we wear. The carbon conundrum is real, and it's causing our planet to heat up, changing climates and disrupting ecosystems. But here's the good news. We have a tool at our disposal to tackle this issue. Its name, carbon capture and sequestration. So what's this carbon capture and sequestration? Sounds like a high-tech ghost hunting technique, right? Well, it's not far off. Picture this. We've got a carbon dioxide ghost on the loose, a byproduct of our industrialized world wreaking havoc on our atmosphere. Our first step? Capture it. We do this right at the source, be it power plants, industrial facilities, or even your Uncle Bob's home brewery. There are 3 primary methods to capture our carbon ghoul. First up, post-combustion capture. This is like catching the ghost after it's already thrown all the furniture around. We capture CO2 from flue gases after the fossil fuel has been burned. Next, we have pre-combustion capture. Here, we're a bit more proactive, separating CO2 from a mixture of hydrogen and CO2 before combustion. Finally, we have oxy-fuel combustion. In this method, we burn the fuel in oxygen instead of air, producing a stream of CO2 and water vapor, which are then separated. Now that we've captured our carbon ghost, what do we do with it? We've captured the carbon, but it's not enough to just catch the culprit. We've got to take it far away from the crime scene. This is where the transport phase of carbon capture and sequestration, or CCS, comes into play. Once we've nabbed the carbon dioxide, it's not just left to its own devices. It's compressed, squeezed down tighter than a rush-hour subway car. This makes it easier to manage, and more importantly, easier to transport. Then it's time for the carbon dioxide to hit the road, or rather the pipeline. These pipelines, specifically designed for the task, carry our captive carbon to its final destination, the storage location. It's a bit like a carbon dioxide Uber, but without the awkward chit-chat. And there's no need to worry about the carbon dioxide getting car sick. It can also be transported by ship, road, or rail if the need arises. We've captured and transported our carbon ghost. But where do we put it? So, we've captured and transported our carbon. Now it's time to lock it away out of harm's way. Imagine you're a detective and you've caught a notorious villain. What do you do next? You lock them away, of course. That's precisely what we do in the final step of carbon capture and sequestration. We store the captured CO2 underground, isolating it from the atmosphere, much like a villain in a high-security prison. These geological formations, often depleted oil and gas fields or deep saline aquifers, serve as our carbon jails. They're carefully chosen for their ability to hold CO2 for thousands of years. Yes, you heard it right, thousands. It's like putting our carbon culprit into a time capsule, a very, very long nap. And just like any responsible jail, we monitor these storage sites to ensure the CO2 doesn't escape. We've got our carbon villain under 24/7 surveillance. So we've captured, transported, and stored our carbon ghost. But why go through all this trouble? Why are we going ghost hunting for carbon? Well, it's not just for the thrill of it. Carbon capture and sequestration, or CCS, is a critical tool in our toolbox to combat climate change. It's like a giant vacuum cleaner, sucking up the CO2 emissions from power plants and industrial sources that are heating up our planet. And it's not just about the capture, it's also about what we do with that carbon once we've got it. We're talking storage deep underground where it won't be causing any more trouble. But like any good superhero, CCS has its challenges. High costs, public acceptance, finding the right places to store the carbon. It's not a walk in the park. And yet our scientists are not deterred. They're developing new technologies to make CCS even better, like direct air capture and bioenergy with CCS. So next time you exhale, remember, we have the tools to capture and lock away that carbon, and every little bit counts in the fight against climate change.